in Norton's theorem, when circuit is given, complicated circuit, then it will be replaced by a short circuit current ISC in parallel with an equivalent resistance Rn, and the terminals, load terminals, are replaced as it is. In any linear circuit consisting of voltages and resistances can be replaced by its equivalent circuit consisting of short circuit current in parallel with equivalent resistance, that is Norton's resistance, and replacing the load terminals as it is. So this is Norton's theorem. So let us see the example for Norton's theorem. Here a simple circuit is given. For this simple circuit we have to replace Norton's equivalent circuit. First of all, we have to short circuit the load terminals, which we will call it as a load. Means if we have a question, the terminals at which the response is required to calculate, I have placed a question that current IL through 1 kilo ohm resistor I have to calculate. So I have placed this 1 kilo ohm resistor as the load, and this is AB terminals I have placed here. If we have to calculate the current through this 2 kilo ohms resistor, then we also place this AB terminals and we will remove these terminals, and we will consider this as the load now, or the response at which the terminals we have to calculate will be AB terminals. So now first of all, wherever the AB terminals may be, short circuit that AB terminals first of all. So I am going to short circuiting this. I will replace the circuit as it is: A, B, 2 kilo ohm, 2 kilo ohm, 2 kilo ohm, and 10 volts. So this AB terminals I have short circuited. Now I have to calculate this short circuit current. Again, to find this short circuit current, we have to remember the current division method. So in current division method, the total current into opposite resistance by opposite plus sum of the resistance will be the current value through any branch. So here short circuit current ISC equals to this total current I total into this is opposite resistance. Why? Because if we are simplifying the circuit, the total current branch resistance never included, because already this current will have these total values. So this resistance never becomes opposite, where the current total of current flowing through that resistance, and again remaining resistance at which the resistances all are connected to one single node will be opposite resistance. That is, this 2 kilo ohms is the opposite resistance now, by 2 kilo ohm plus this other total resistances. Only 2 kilo ohms are represented here, so this 2 kilo ohms I have placed. If there is any additional resistances, then the total resistances we will simplify using series parallel combination, then we will place this total resistance in this place. Here I don't have only 2 kilo ohms resistance is there, I don't have any other, so I have placed 2 kilo ohm resistor directly. Now I total we don't know actually. This I total we have to calculate. For calculation of this I total, we have to simplify this total resistances. This is two parallel resistances, that is 2 into 2, 2k into 2k by 2k plus 2k, so that is 4 into 10 power 6, k into k becomes 10 power 6 by 4k. So this we get 1 kilo ohm, and next this is 2 kilo ohm in series, so 2k plus 1k becomes 3 kilo ohms, and I total will be equals to V by R, 10 by 3k, that is 3.3 into 10 to the power of minus 3, because this is 10 to the power of plus 3 becomes minus 3. So I total is 3.3. Now 3.3 into 10 to the power of minus 3 into 2k by 4k, 1 by 2, that means 1.62 1.65 into 10 to the power of minus 3 ampere. This is short circuit current. And second step is to find Norton equivalent resistance. To find Norton equivalent resistance, short circuit the voltage sources and open circuit if any current sources are there. Here it is no current source is given. Short circuit this voltage source, that's it. So now we will replace this circuit as 2 kilo ohms, 2 kilo ohms, 2 kilo ohms. These AB terminals are ignored. Through this only we are calculating total current, total resistance. So these terminals doesn't means that it is open circuit. It is not open circuit like this. So this total equivalent resistance will be calculated based upon series parallel combination of resistances. So there is a resistance here. Don't think that this resistance is opened. So these terminals are connected means 2 kilo ohms and R equivalent is the series combination. So 2 kilo ohm plus this resistance is in series with this. So I have taken 2 kilo ohm as the series resistance and these two are in parallel. 2k into 2k by 2k plus 2k, that is 4 into 10 to the power of 6 by 4k, that is 1k plus 1 into 10 to the power of 3 plus 2k. So R equivalent equals to 3 kilo ohms. Now replace the circuit. Norton's equivalent circuit saying that replace the total complicated circuit by a short circuit current in parallel with Norton's equivalent resistance and replace the terminals as it is. We will replace, we don't include in any equations to solve this. We replace this AB terminals at the last of the equivalent circuit. Now we have to calculate this load current. Now IL equals to, again we will remember current division method. ISC into RN by RN plus RL. ISC is already we have calculated in the previous value, that is 1.65 into 10 to the power of minus 3 amperes. 1.65 into 10 to the power of minus 3 into RN is 3 kilo ohms by 3 kilo ohms. This is 3 kilo ohms we already calculated, plus load resistance is 1 kilo ohm, that is 1.65 into 10 to the power of minus 3 into 3 by 3k by 4k. So that we get value as 0.75 into 1.65 into 10 to the power of minus 3 into 1.65. 1.23 is the answer into 10 to the power of minus 3 amperes. That is answer. Like this we have to calculate the response or the current through any element.